Hi everyone. Last time we created a model for our data, which is displayed there. This time we're going to use the technique of residuals and we are going to optimize this model. So I'll just slide that over a bit to give myself some room and I will start to calculate residuals. Now, what is a residual? A residual is the difference between the data point and the prediction made by the model. So I'll need a formula. The data value in my first one is 13.85 and their difference means to subtract, and the prediction was 13.793. So now that was annoying that it jumped to so many decimals. I'll just drag that back to about 3 or 4 decimals and I'll make that column a little bit narrower again. How wide are these columns? 96. Okay, 96. And I'll copy that down. So these are my residuals. Now, in this first one, it's a small positive number. It means if I were to zoom in here, the data point would be slightly higher than the model. And then down here, I get to some small negative numbers. It means the data point would be slightly lower, slightly below the orange line. Because these are sometimes positives and sometimes negatives, you may be tempted to do an average of the residuals, but the positives and the negatives tend to counterbalance. So even though they might be quite large residuals, if they're positives and negatives and they counterbalance, your average will still come out close to 0. It's a little misleading. So what we do is we square the residuals. I will take that number, and that little funny arrow is above the number 6, and it means to the power of, and I'll put 2, so it's squared. Now, a small number times a small number is an even smaller number, so I'll need a few more decimals on display there. 5 decimals should do. And interestingly with these, even a negative number squared becomes a positive number. That's why we square residuals. That way all of them are positive numbers. And in an ideal world, the model would exactly match the data point. If these two exactly matched, the residual would be 0, the squared 0, it would still be 0, and then all of them would be zeros. So we can get an estimate of how good our model is if we add up all of these squared residual values. And that's exactly what we're going to do. So I might just move those little ones down a bit so I've got some space here. And this is the sum of the squared residuals, or sometimes the residual sum squared is what it's referred to as. And there's a formula called sum, which I can use here. Control Shift down arrow, close the brackets and then hit enter, and that number represents all of the squared residuals added together, 1.56. That's a pretty small number when there's quite a number of data points there, but we can probably do better. And this is the part where some Excel automation comes in. So I'm going to go to my data tab and I'm going to use the solver add-in. Now, this was one of my earlier videos about how to make sure that's there. If you don't have solver on your Excel, go and check that previous video. So I'll hit solver and I get this dialog box. Now it's asking me what I want to do. Oh, what's my objective? My objective is this cell here, F6. I want it to be a minimum, because the smaller the residuals, the smaller the squared values, and I add them all up, I'll get a smaller answer, by changing these 4 numbers here, by changing my parameters. If I could, now it's not me this time, Excel will employ an algorithm. There's a few different ones, but that seems to be the best one with the default one, and I'll hit solve. It tells me that it has converged to a solution, and if I take that away, I can hit OK. Now, a moment ago that was 1.56. It is considerably smaller than that now, 0.03. is a very, very small value for adding up all the squared residuals. It has adjusted my parameters slightly compared to what I had. Last time I had this as 12. It's bumped it up to 12.16. I had this as 1.8. It's taken it slightly to 1.72. This was 1. It's slightly different. I think that one was 95. But take a look at my graph. I'm going to have to zoom in a bit to see this clearly. The orange line is almost a perfect match for the blue X's. The data points are being modelled extremely well. I can say that it's a good model for a number of reasons. First, it's a very good match on the scatter chart. Second, the sum of the squared residuals is an extremely small number, and that's also a good sign that the model is doing its job. So that's it for this instalment. We have taken the model we already had, and by using residuals and then squared residuals and then summing the squared residuals, we have used that number there as a measurement of the quality of the model. The smaller that number, the better the model. And I use the Excel solver add-in to automatically optimize my parameters. Thanks for watching.